the buzz in the world going on right now. We've got two really good people to do that. We're going to have two sessions. We're going to have two sessions, presentation, then some questions, second presentation, questions, and then at the end we'll have announcements if you want, and if you want to save more questions afterwards, we'll probably keep these guys for a little while longer. They don't have to be in for tomorrow morning 9, so they've got essentially all night. Sure. All right, well, let me introduce Shauna, who's from Elasticsearch. He can introduce the speakers, and he may have some things to say too, so thank you for coming. Hope you enjoy it. And I think we may have a recording of this after we're done. I'll post it up to the Meetup page, so you find it there. Thank you.
Hi everyone, welcome. You need to get on the Wi-Fi. Password is here. If you haven't got any food or drinks, it's at the back over there. So make yourself at home. We have two fantastic talks today. The first talk is from Krijn. Krijn's been at Elasticsearch for a little over 6 months, and he's a solutions architect here, which means he's seen a lot of different deployments, a lot of different problems, a lot of different customers and use cases. So it should be a very informative talk. And then the second talk is by Andrew Selden, who works on Elasticsearch Core. He's here somewhere. He's been at Elastic for a year and a half. So again, should be very, very interesting talk from him. He's going to talk about aggregations. But first, just an announcement. A lot of the food and drinks back there and the space is possible because of Elastic's commercial plugins, Marble and Shield. Marble is the operational dashboard that you could use to visualize your Elasticsearch cluster and monitor it. And Shield is the security plugin. So if you want to learn more about these products, talk to Sandy over there. Sandy, if you want to wave. These are our commercial products, and that's what makes a lot of this possible. And with that out of the way, please help me welcome Krijn.
Hello everyone. Can you hear me? Yay, it seems to be working. That's always good. Hi. So let me start off with a question real quick. How many of you know what the Elk Stack is and what it does? Okay, a fair amount, but not that many. So before let me do it at the end. I'm going to show you a demo that shows you what you can do with the Elk Stack. And then afterwards, I have a few slides very briefly that give you an overview of the stack and the various modules that make the stack up. So that hopefully will give the people that are not too familiar with it a bit of an overview. So let me start with this demo, first of all. So let me give you a little bit of background here. So the data that we're working with is simply a few days of Apache web server logs that we've gathered between the 5th of January and the 21st of January. We then used one of the components of the Elk Stack, Logstash, and we will get into the details of that in a little bit, to parse it and to ingest it into Elasticsearch. And so on top of Elasticsearch, we have Cabana, which is our visualization product. And so all of these three elements of the Elk Stack are open source, so you're all free to download them and play around with them. And what I'll be doing here is give you a little taste of what's possible with Cabana when you have, a logging type data set present in Elasticsearch. And please, if there are any questions, we're going to have a Q&A session at the end, so if you could save for that, that'd be great. So let me start by pointing out the first visualization right here at the top left. So what this shows is simply a histogram on the daily level. So basically for each day, it shows you how many requests were recorded. And we've subdivided each of those bars as to the response code that was returned to that request. And so it's basically two types of aggregations that you're seeing here in one visualization. And my coworker Andrew will be getting a lot deeper into those aggregations afterwards. And so, a couple of things immediately become clear here, right? We see, for example, and if I hover over the legend here, you can see, the corresponding aggregations highlighted. We see, for example, there were a few days where there were a lot of 404s. There was a huge spike on this particular day here. And one of the good things about Cabana is that it allows, all the visualizations are interactive, so it gives you a very easy way to drill down to filter your data. So for example, if I click here, I'm filtering on, and I need to confirm that choice real quick. So now I'm filtering on the response code 200, okay. So now everything is filtered by that value. So all my visualizations here immediately reflect that. As you can see, they all changed. And if I remove that filter, which shows up here at the top left, they will all change back again. And so that highlights one of the characteristics of Cabana, the fact that it itself doesn't really do any processing. All it does is it sends queries into an Elasticsearch cluster, and it renders the results it gets back into the visualizations that you have set up before. So that means if your Elasticsearch cluster is sized properly, has been scaled properly to the amount of data that you're trying to analyze, your results will always be near real time. And by that I mean that they become available for Cabana once they've been indexed in Elasticsearch. So we like to say near real time because obviously there's some processing going on and the indexing itself takes a little time, but once you start that process, within a few seconds it'll be available for Cabana. And the other advantage of that is that you don't need to scale Cabana itself, right? You only need to scale the Elasticsearch cluster. So Cabana itself is very lightweight, so you don't need to worry about the resources it will consume. Now, that second visualization here that I'd like to have a closer look at shows us the cumulative bandwidth used over time. And so I've subdivided that visualization per country. So we've used GeoIP database, and so by hovering over certain peaks, I can see, for example, on this date, there was a huge peak from China. So that may be something I want to investigate further. The donut type graph here is on the inner circle, it shows the response codes again, but then those response codes are in this case subdivided by the country that the request originally came from. So what you can see is that when I look at the 404s and then hover over the largest subdivision there, that apparently a lot of those 404s came from Indonesia. Again, that may be a handle for me to start investigating what happened there. Maybe my marketing department messaged a URL wrongly and a lot of people were trying to reach it and we're getting 404s instead. Now, if I scroll down a little bit here, you can also, with Cabana, you can very easily set up table views of your data. So in this case, we are just simply showing the top 20 agents that we have in our data set. So you can see that apparently we had a lot of requests from the chef client. So apparently somebody set up a recipe using something coming from our website. So if I just quickly click on that and filter by that particular client agent, I can see that I actually only get one URL. So apparently somebody wrote a recipe that's using this particular jar here and deployed it on a lot of different nodes. As you can see, there's a pretty significant number of requests for that particular jar. So again, filter shows up here as a little tag, which I can remove. And so since we've processed the data in such a way that for each and every request we've looked up where it was coming from, we can also visualize it on a map. So let me zoom in a little bit here. And so that gives you a pretty quick overview of where most of your requests are coming from. So a lot of them are obviously coming from Western Europe as well. Excuse me. There we go. As well as from the western, the coasts of the US. With Cabana, it's also very easy to just put particular metrics that are important to show to the people that are monitoring, your analysts or users, in a single panel like we're showing here. We're showing the total count of records as well as the count of unique IPs that we've recorded. All right, so before I move into the next section, any questions so far about what I've just shown you?
Do you have like heat map on the map?
Right, so the question is, do we have a heat map? In the current version of Cabana, the mapping works so that you can have a circle represent either by color or by size the count of the particular aggregation that you're visualizing. So that's not a heat map in the sense that you are actually coloring a particular geographical region in a certain way, but you can. It works by geohash. So you can see, at a glance, what the particular metric is for each geohash location. Anything else so far? Good. All right, so the next bit that I wanted to show you is actually make a visualization real quick ourselves. So let me move out of that real quick and move to a different tab. So in this case, Cabana has a number of available visualizations, most of which we saw in the dashboard just now. So let's say that I'm interested in a vertical bar chart. And then the next question it asks me is if I want to use a search that I saved earlier, or if I want to work from a new search. So the reason I might want to search from I might want to create a visualization based on a saved search is that it kind of gives you an implied filter. So remember when I was clicking on the 404s and filtering in on that, I could save a search like that, which could also be just a certain keyword, and then just build that filter into my visualization. But in this case, I'm just going to do a completely new one. And then it lets me select an index pattern. So an index pattern basically is nothing else than a wildcard expression that tells the system which indexes do I want to visualize against. So in this case, it was log stash star. So right now I'm executing my visualizations against all the indexes that start with log stash, which is what we put our web server logs into. So initially it's just a big block because all it shows now is the count of all records. So let's add a little bit more interest here. Let's say we want a term-based aggregation on the x-axis, and let's say we want to do that on the, well, let's say geo-IP country name. There we go. And let's say I want a maximum of 20 countries in there. So now I just click apply, and I immediately get that bar chart. So this basically gives non-technical people a very easy way to create their own visualizations. And then once you've saved those visualizations, you can put them together in a dashboard like the one I showed you earlier. Now this still, it's a pretty simple bar chart, so let's make it just a little bit more interesting. So if I add a sub-aggregation, I tell it to split up the bars to another term aggregation. And let's choose another field. Let's do user agent. Name of user agent, there we go. And not to make it too crazy, I'll just leave it at the top 5 of those. So now, it shows me per within the top 20 of the countries which user agents were used for the requests coming from there. So again, by hovering over it, I get a bit more detail. So in this case, United States sees a lot of requests coming from Chrome, Firefox, Googlebot, IE, whereas the requests from Brazil are much more where the name of the agent is simply set to other, compared to France, where the majority actually seems to be Firefox. So that gives us a quick, insight as to what user agents are being used, at least for people coming to our website. So like I said, you can just save a visualization like this, and then once you've saved it, you can put them together in a dashboard, and that's kind of the workflow that Cabana has been built on. There's, as you can see up top, the Discover tab, which I won't go into right now, but which gives you a quick overview of your data, and then stop that. I think you believe me if I say you can save it, since we saw the results on the dashboard already. And then visualize, create your visualizations, save them, and then put them all together in a dashboard. So that's the basics of Cabana that I wanted to show you. And like I promised you earlier, I do have a few slides that kind of give you an overview of the Elk Stack itself. But before I launch into that, any questions about Cabana visualizations?
A couple of questions. One, how can I export dashboards out so that I can move from one Elasticsearch instance to, say, a different Cabana?
Right, so the dashboards are simply saved in Elasticsearch, so they're saved in a specific Cabana index in Elasticsearch. So you can just back up that index and restore it in a different Elasticsearch instance.
Okay. Two, assume you have two logs, like click-through logs and query logs from a search engine. How can I combine them together and display them in Cabana dashboard so that I can use both the click-through information and the search information together?
Right, so the question is, if I have two types of logs, let's say an application log and a server log, how can I put them both into Cabana and to perform perhaps visualizations based on both of them? So the answer to that is, well, first of all, let me explain that one of the characteristics of Elasticsearch is that you don't need to define a schema before you start indexing. So you can just, when you're indexing data, fields get added on the fly to a particular index. And of course, you can influence that process. You can configure, if you want a particular field to always be there, you can configure that, or you can configure, how particular types of data are interpreted as field types. But the actual creation of the fields happens automatically. So you could index the log information from two different sources into one and the same index, and then your fields would just be a union of the fields that are present in those two logs. Or you could save them, you could index them into separate indexes, which would give you, which I would recommend, because that gives you a much better way to manipulate the data from those two different sources. And another good thing about Elasticsearch is that you can apply queries to more than one index. If you can, like I just showed you, Cabana asked me to define which indexes I wanted to run my visualizations against. And so that works exactly the same if you just run queries in Elasticsearch. You can say, I want this query to run against this set of indexes. So once I have that, I can just make sure that I tell Cabana to work against those indexes, and I've put my data in from those two sources, and then I can just create visualizations. Any others? Sure, go ahead.
Back to the exporting question, how can I export it to Excel?
To Excel, well, so you can, when you have your data in a tabular format, so let me go back to my dashboard real quick. When you have your visualization, when you have this visualization as a table, like for example, the top 20 of URLs right here, you can actually export it as, for example, a CSV. So that way you can easily import it anywhere else. Does that answer your question? Okay, great.
Is that a real-time visualization? If it is, how did you do that?
How do you know it?
No, how do you do that from a back-end perspective? Real-time visualization.
Okay, sure, I can talk to that. So the question was, is it real time, and how was that set up? So in this particular demo is not real time. So this is on a particular time frame, between what was it, January 5th and 21st of this year. But if you have one or more systems that produce logs, you can set up Logstash in such a way that it continuously parses and ingests that log data into Elasticsearch. And so that Elasticsearch is near real time, so it becomes, once it takes a few seconds to index everything, but then it becomes available for query. Once it is available for querying, it becomes visible in Cabana as well, because all Cabana does is send the query and render the results of that query. So as soon as the data becomes available in Elasticsearch, it's available in Cabana as well. Does that answer your question?
Yeah, so it's still early on prep.
I'm sorry, I cannot hear you.
It's not available right now.
It's not available right now, the feature. Because it's like near real time. If I'm asking for being updated every minute or even every second, that will be require streaming processing. I'm not sure. Elasticsearch supports streaming type of transaction.
It does. You can
do every 5
ingest.
seconds.
You can ingest. You're probably ingesting the access log, correct? The Apache access log. Sorry. You're probably ingesting if you're ingesting the access log gets read in real time. You just have your Logstash read in real time, and that will go into Elastic real time. And every time your dashboard refreshes, it'll be real time.
Yeah.
The one comment I have though is look at what the load factor might be of ingesting the logs real time. Does that add any benefit to do that?
And you can refresh it every
So-
5 seconds. So, yeah.
Yeah, so you're right. So an initial remark is that you can set Cabana to refresh itself every so often. So that you don't, if you're have a big old screen in your war room and you want to keep everyone up to date, you can set Cabana to do just that.
So if I have to share this dashboard with someone, is there anything in the roadmap to add login authentication to the dashboard so I can share it out?
Yes, in fact, it's already there. So there's one of our commercial plugins. It's called Shield, and Shield gives you a way to authenticate users and control what they have access to. And so it also, Cabana plugs into that. So Cabana, if Shield would be installed on this particular demo, I would load Cabana, and it would give me a prompt for a login. And so then, if my user doesn't have access to a particular index, I can't make any visualizations based on that index. And that actually, I think, is a nice segue. Oh, one more question, sure.
So a related question. So how do we save just the filters? Like I know, like if we save the dashboard it saves with the filters and we can share the link. But how do we just save the set of filters? Because the use case I'm looking for is like, I experiment with bunch of filters, then I would maybe just want to save like with some custom names, like, and come up with like a history, and that way I can easily jump across them later.
So if you're what you can say, for example, is a search. And so you can build your visualizations based off of a saved search. So if your filter is based on a particular keyword or a set of keywords or a more complex query that you've saved, that you can use that as a filter. And you can save it separately, and then once you build a visualization, you can say, okay, do everything in this visualization, everything should be filtered by this particular query.
But then it becomes like, let's say I need 5 filters, sounds like I need 5 search and then 5 different visualizations.
I'm sorry, I'm having a hard time hearing you. I don't know if you still have the mic.
Okay. So sounds like let's say if I want like 5 different filters, if I want to save 5 filters, sounds like I have to save 5 different searches and create 5 different visualizations.
Why not write a query that does all 5?
I mean, I can write a query, but maybe like someone on marketing side, or customer support, they would not.
Fair enough. You're right, and that's that is probably not. That's for somebody who doesn't know exactly how the DSL works. That might be a bit of a hassle. So yeah, I mean, that's maybe something you want to submit as a feature request.
Let's keep moving and hold questions for the end. Sorry.
If you don't mind, I just want to show my few slides. It's only like 5 slides that I got. So, okay, there we go. So yeah, by now with all the questions we've been answering, you probably have a pretty good idea what the Elk Stack, what the Elk Stack consists of. But I just wanted to go through each module real quick so that if those people who are less familiar with it get a better idea. So ELK, Elasticsearch, Logstash, Cabana, and the data flow starts with Logstash. Logstash collects logging data. That's how it started its life, as a way to collect logging data and parse it. But there are, over time, more and more input plugins have been developed that allow Logstash to get data from all kinds of different sources. So it's become kind of a general data gathering mechanism. So within Logstash, you can define how it should parse the incoming data, and then it will talk to Elasticsearch. It will actually store that data in Elasticsearch, and like I mentioned, you don't have to create a schema or anything beforehand. All of that can be done on the fly. And Elasticsearch, has been designed from the ground up to be as scalable and as fast as possible. That's kind of the philosophy of Elasticsearch, which sets it apart from other information access platforms, in that it makes it very easy to scale out. It's very easy to add nodes to a cluster, and it's very easy to manage a scaled out Elasticsearch cluster, because a lot of the management work is done by the cluster itself. For example, if I've configured my cluster to have a certain level of resiliency, it will replicate some of the shards that make up my indexes, and you can actually configure it per index, and it will take care itself. It will work itself. It will redistribute the shards in such a way that if one node drops out, everything gets rebalanced, and I can still perform all queries. All the data will still be available. And then on top of that, of course, Cabana, what we've been looking at all this time. And Cabana, like I showed you, is a really easy way to build visualization, but it's not by a long shot the only way you can interact with Elasticsearch. In fact, one of the pieces of feedback we hear most often when we're at customer events is how easy people find it to build applications on top of Elasticsearch and create their own front ends or other types of applications that fire queries into Elasticsearch and take the results and do something with it, visualize or do whatever with it. So those are the three main components, which are all open source. But then, in addition to those, we have what we call the commercial plugins that Shanek referred to in the beginning already quickly. And if you have any interest in those, please talk to Sandy over there in the back. Which are Marvel and Shield that are out right now. Marvel is a tool, a plugin that's built on top of Cabana and shows you very fine-grained metrics about your Elasticsearch cluster. So it gives you a way to get real-time information about your cluster and immediately see the status of the nodes in there. And then Shield, like I explained, gives you a way to secure your cluster. Shield, by the way, integrates with LDAP and Active Directory, and so you can authenticate users against those repositories, but it also has its own user database that you can use if you have the need for it. And it also allows you to secure inter-node communication over SSL. So it hardens your deployment in various ways. And then in the very near future, we'll be releasing another commercial plugin that gives you alerting functionality. You may have noticed by now that there's a bit of a Marvel superhero theme going on with Elasticsearch. So the alerting plugin is going to be called Watcher. I don't know if there's Marvel fans in here, but I suggested Uatu, which is the actual name of the Watcher, but they didn't go for that. And so that'll give you a way to predefine queries, and if the conditions that you define in those queries become true, you can configure a particular action to take place. So, for example, if you do it against Marvel, you can build a trigger, for example, that says, if on 50% of the nodes in my cluster, if they get over 80% of memory usage, send an email to my ops guy. Queries like that. But you don't have to do it on Marvel type data. You can do it against any type of data that you've indexed. So yeah, that's what I wanted to tell you about the Elk Stack. Question?
So, excuse me, can you talk through the deployment architecture where, if I have like 20 visualization in the dashboard and like 30,000 records in Elasticsearch, Cabana was a bit slow. I was running in my local Mac, but in a production, typically we would index 30 million logs. What is the best configuration from a Cabana Elasticsearch perspective so that you get the most? Do I need to repeat the question?
No, I think I got it.
Okay.
So to summarize, your question was, what are basically the scaling characteristics of a typical deployment where I'm using Cabana?
Right. I'm assuming like 30 million logs and really fast performing Cabana dashboards.
Right. So, like I mentioned, Cabana itself doesn't really do that much. It just fires queries. So what you'd be scaling is the Elasticsearch cluster that it lives on top of. And so when we work with customers to come up with an architecture that includes all the scaling, there's a couple of variables that we take into account. There is how often is data refreshed? So, for example, how many events per time frame are occurring in the systems that you are logging, that you are taking the logs from? What's the expected query load? If you're expecting lots of people to fire off queries into the system, we may want to scale for that as well. And then, of course, we want to get a sense of what's the total data volume going to be, what's your retention period. You know, all of those impact the data volume and will impact the number of excuse me, the number of nodes that need to be present in an Elasticsearch cluster in order to ensure that your queries are still performant. So yeah, that's a really long-winded way to say it depends, I guess. There's not really like a really, you know, there's not one single answer to that question.
Is it a benchmark that you've done on Cabana?
We are in the process of creating, you know, several benchmarks. Right now, we don't really have a nicely formatted set of benchmarks that we can publish, but we're working on that.
Can you talk about the roadmap of Cabana? What's next in Cabana?
What's next in Cabana? I can talk a little bit about that. Don't know if there's anyone from Elastic present here who has more of a sense of the roadmap, but in any case,
I wouldn't go there. You know, it's like we're trying. So we're trying to be a lot more organized in the way that we're publishing our roadmap, especially for the open source. So we have started pages on our website where, you know, because there's so many requests for features in GitHub, it's become really difficult for people to try and keep track of what are we working on and what are we not. So what we've done is we've created pages on our website where we are detailing what are the features that we're working on, what's going to be coming in the next release, and really trying to make it a lot easier to be able to see and be able to visualize that so that you can kind of see. And you know, we're always looking for feature enhancements. So if there are things that you're seeing that we don't have, we definitely want to see those requests. And we do take a lot of feedback on things like that. But we are also trying to be a lot more organized in the way that we're communicating out what are our next steps, what's coming in the next version. So I don't know if we've done that for Cabana yet.
No, it's Logstash.
So Logstash is done. If you look at, do you know where it's posted?
It's in the Logstash guide.
Okay, in the Logstash guide, you can see what's the coming next, and we're going to be publishing that out for Cabana and for Elasticsearch as well. So we just aren't there yet, but they're actually going to be coming pretty quickly. So if anybody has any specific questions about, you know, what's coming next in Cabana, you know, you can reach out to one of us and we can help set up some sort of a roadmap discussion. But there's a lot of information out there.
I think we're all going to
If you go to GitHub, there's a roadmap label in GitHub. You just click that and see what's coming next.
Okay, there you go.
Awesome.
What I was going to say was I think we're all going to be reaching out to you. We'll be looking at GitHub, but you might want to do the next meetup to actually just go.
Sure, I guess we can try and to set something like that up. Yeah.
Yeah, we covered a lot of that kind of stuff in Elasticon. And if you go to our website, under if you go to elastic.co/Elasticon, all of the slides and the videos that we have. Unfortunately, there was a snafu with some of the videos, but all of the slide decks are actually posted up there on our website. And that was that user conference was just held at the beginning of March, so the information that's in there is really very current. And all of those slide decks are up there, and they have all of that. So there's one for Cabana specifically, one for Elasticsearch.
Yeah, Rashid, the creator of Cabana, he spoke about what's coming.
Yeah.
Cabana, it's the same thing for Elasticsearch.
I'm just curious, how do you guys manage to make your cluster truly elastic from hardware architecture point of view? I believe in terms of software architecture, it must be truly elastic. But how do you manage to make your cluster truly elastic? Do you right now, truly auto scaling? Can you auto scale your cluster?
So we have a concept called core allocation. So that's the theory behind Elasticsearch. So
fact that we have shards, we distribute the documents, Elasticsearch based on shards. And shards can live on different machines. So you basically have more shards than nodes. And then as you add more nodes, the shards can be.
What kind of database is
It's we don't use any database. It's a file-based storage. And Lucene is the engine behind Elasticsearch. It's file-based. Yeah, so you really don't want to split a shard into multiple shards. It involves copying data. So there's ways to mitigate that by designing your data. So if you use time-based indices, you really don't have to split an index with more shards. You can create a new index for a new date with more shards. So that's a, even for analytics, the indices are created in Elasticsearch. It doesn't matter which Logstash, it doesn't matter what you use. That's contained solely in Elasticsearch. If you use time-based, if you use user-based, if you have a new user who's more versed in the feature, you can create more shards.
So how do you stream the data from like Logstash or whatever I do to Elasticsearch? And the second question is, like let's say I have another data store, like let's say like my data in Mongo or MongoDB or Cassandra. How can I stream that to Elasticsearch?
Right, well, so to start with your first question, Logstash simply talks to the Elasticsearch API. So it just sends the data through that so that it gets indexed. As to your second question, I actually don't have a really good answer for that right now because that's sort of outside my purview. I can follow up on that and I can see if I can come up with something and post it on the Meetup page, something like that.
Yeah, or we can address that afterwards as well.
Sure, yeah.
There's definitely ways to do it. So thank you, Krijn, so much.
No problem, no problem.
Really appreciate it. I want to make sure that we have enough time for Andrew's presentation. So Andrew's going to come up and dig a little bit deeper into aggregations in Elasticsearch. And this actually ties into what Krijn's been showing you, because he's been showing you, how Elasticsearch, Logstash, and Cabana work together. And you can do a lot of aggregations within Cabana. But Andrew's going to drill in a little bit more specifically into aggregations themselves and how those are utilized in Elasticsearch. So Andrew Selden is one of our core developers on the Elasticsearch side, and a really great guy.
Hey.
Thank you, Krijn.
All right, hi everyone. My name is Andrew. So thanks to Krijn for that really great intro to Cabana and the Elk Stack. So what Krijn showed you was how Cabana was actually talking to Elasticsearch and then getting a bunch of raw data points back and then drawing these really cool, really pretty graphs that give you a lot of information. And that updated really fast in real time. So what I'd like to do is just pull back the covers a little bit and just look at the facilities in the core Elasticsearch engine, which actually make that possible. So Cabana just talks to Elasticsearch through public APIs and just gets a bunch of JSON data packets back and then draws those pretty graphs. So let's pull back the screen a little bit and see what's really going on. But before we can talk about aggregations, we should understand where they came from. So for a long time in the search world, we had this idea called facets. And facets were just like what you see here on the screen. When you go to any kind of website like a LinkedIn or an Amazon or any kind of like a hotel booking site, you always have your main screen and then typically some kind of left nav that breaks down data by some key attributes. And so this is what we've traditionally called facets. And they've been around in Elasticsearch and in the Lucene world for a long time, and should be nothing new to you there. But this is really the heritage of where aggregations came from. And we kind of internally sometimes refer to aggregations as facets 2.0 or facets on crack or something like that, because it's sort of taking the basic idea here to the next level. So prior to Elasticsearch 1.0, Elasticsearch pre 1.0 had a lot of facets built in, a lot of core facet functionality built in. You could facet on terms, or do range facets, or date histograms, or any kind of geodistance attributes we could build facets on. So let's just take a look at what that looks like. So for a terms facet, we would basically divide all of our documents into what we call buckets. And those buckets would be determined based on some value of some term in our data set. So for example, suppose we had a data set of a large index of US cities with population metrics, land area, population density, lat long, geolocation, and some other basics about big cities in the United States. Well, a terms facet, this pre-aggregation idea, this pre-Elasticsearch 1.0 facility of term faceting, very easy to use. We just say, hey, we'd like some term stats on this database of states, and we'd like to break it down by density. And so we'd submit that to Elasticsearch, and what we'd get back from the Elasticsearch API would be just a big JSON payload that had a bunch of key metrics, and as you can see, they were indeed broken down by state. So see California, and within California, we have some key metrics there, and then Texas, and for Texas we have metrics, and then Florida, and so on and so forth. So nothing too groundbreaking there. And of course, we could facet on different fields. So population density. You do the same thing based on population density. And this is all well and good, but what happens when you want to dig deeper? When you want to facet on your facets, you want to dig down and get even more rich data. One of the main limitations of facets was that they're really just sort of one level view. So in Elasticsearch 1.0, we introduced what we call aggregations. And aggregations are based around the idea that we can bucketize our data, or rather, we can group our data into any number of arbitrary buckets. And within those buckets of data, those collections of data, we can further bucketize. And eventually, what we want to do is run some calculation, run some metric aggregation on the contents of these buckets. So for instance, working through this example of the state data, our buckets in this example would be the states: California, Texas, Massachusetts, Colorado, and so on. And what we did in the last example with facets was we just did a top-level, single-level calculation on population density. Great. But the real power and beauty of aggregations comes from the fact that we can dig down deeper and deeper to build a sort of tree structure where the internal nodes are all buckets, and we can have sub-buckets and sub-buckets and sub-buckets, and then the leaf nodes of our tree are calculator nodes. So we can arbitrarily divide data into several, mix and match into several, along several dimensions, and then finally calculate some statistics there. For example, if we want to get the mean density of a state, we can define an aggregation on the state field, and then let's do just an average then we can calculate the average, a simple mean average on the density. And again, it looks pretty much like what we saw in the last section. The states here are buckets, and then the mean density calculation will correspond to a leaf node, which will be a calculator node. But we can go even deeper than that. So we can make states our top level bucket, and then we can make another bucket for population, and within that we can have a mean density calculation. So we can go within, as you can see, we can take our top level buckets and keep subdividing and subdividing. So in this case we have a state, California, and we've first broken out to bucketize by population. So, and then within population, we've calculated statistics on population density. So for population 0, mean density has a set value, and then we bucketize them based on value ranges. And this can be really powerful and allows us to just arbitrarily ask questions that we might not have been able to ask before. So out of the box, Elasticsearch comes with a couple of core aggregations: average, min, max, sum, count, stats, and extended stats. And there are a lot more that you can play with. I encourage you to go to our website. The documentation page on aggregations has a lot of great information. And we even have more bucketizers. We can bucketize based on IP ranges, histograms, geodistance, even nested fields. And then coming up in 2.0, we'll have what we're going to call aggregations 2.0, or internally we call them bucket reducers. And this will allow you to actually apply arbitrary mathematical functions on the buckets, on the intermediate values of the buckets themselves. So you'll be able to calculate first, second derivatives, moving averages, do outlier detection, or even write your own custom bucket reducers. So that's it. It's just a whirlwind introduction to aggregations. Are there any questions?
I have a question. So you mentioned that we can have a bucket for your example, we have a bucket for state, right? And I want to have another level deep down on that, let's say the bucket for a range of age by 0 to 10, 10 to 20,
sure.
20 to 30, something like that. Are we able to support that kind of use case that we have a bucket in the bucket?
Absolutely, that's exactly the motivating idea behind coming up with the aggregations framework. Is that, so to take that case, if we want to break our data set down by state, right? And then what this diagram is showing is that, see the small buckets? So the idea there is that within each state breakdown, you can further break it down based on any dimension of interest to you. So it could be broken down by age, could be broken down by socioeconomic status, income, could be broken down by gender, could be broken down by voting patterns. And again, within those sub-buckets, we can go even deeper.
Do we have to define the index or the schema for those category, bucket over the bucket?
There's no, as with most things in Elasticsearch, there's not a lot of upfront schema design that you have to do. Generally speaking, with Elasticsearch, you can just start feeding data into it, and it will do what we call dynamic mapping, which is basically schema inference. So we just build up a schema for you on the fly. You don't have to do anything ahead of time to prepare your data to be amenable to this. It just works.
But then how can it make sure that it can return me the result in the certain time? Let's say I want the result within 100 milliseconds or at less than 1 second. And if you didn't index it beforehand, then it's gonna take a lot of time to process all of that.
Well, everything is indexed by virtue of being in the Elasticsearch.
But it's indexed by field, right? By the column only. It's not indexed by a combined field, right?
Correct. The indexes are based on a field, not a combined field. With respect to your question of how can we guarantee something executes within X number of seconds or X number of milliseconds, the answer is we can't. The speed with which something executes will be influenced by a number of factors, such as the kind of hardware you're running, the kind of data that you have, the kind of queries that you're expressing. But generally speaking, yes, it's sub-second.
And then how can we do aggregation between different shards? I mean, the data spread across on the shard, and we want to do aggregation like on different shards.
Between different shards?
Yes. Okay.
So the way things execute in Elasticsearch, as you know, is that we sort of scatter out to all the shards in a distributed way. The shards will execute what they have to execute, and then bring back the intermediate results to the calling node. The calling node will do a stitching together of the results there on the calling node. So it's just a basic scatter-gather approach.
I have a question. I have a question regarding scaling of applications. So let's say that we have a corpus about 50 or 100 million documents, and each document has a user, and we are aggregating based on the user count. So as the number of users increase and the number of counts, so the counts increase. So so for example, let's say the one user has got a count of one user has a count of say 10 million documents, and there are so many users. So what we are seeing is the coordinated node, which is doing the computation, is taking a long time. The CPU is speaking. So what kind of scaling strategy would you advise where the number of these buckets are large, the community is large, and the counts are large?
Okay, so just to read that back to you to make sure I understood it, you have a database of users that's quite large, and your aggregations are taking a long time on the coordinator node?
Yes, the database has got documents, and each document has a user as one of the terms.
Okay, but the core issue is that the coordinator node is taking time.
That is correct.
Right. Okay, so the coordinator node in this case is the node that accepted the request and is going to do the aggregation. But in order to get the data, you have to delegate out to some number of data nodes, which do some computation, and then bring the data back to the coordinating node. And what you're seeing there is, as the coordinating node is assembling the constituent data parts from the data nodes, you're seeing CPU spike there. Well, basically it's doing what it should be doing, right? It's using CPU because it needs to do a final computation on the sub-results. Now, with respect to making that faster, essentially when you get back to the last step in the process, it is essentially a single-threaded process there, where you're assembling, doing a merge, sort, or whatever of results. Without knowing specifically the kind of aggregation you're doing, I can't say if it's a multi-CPU computation or not. If it is, then we can try scaling it out horizontally, but other than that, I think it's really... It may be an issue of just CPU speed or memory.
With the communication between different nodes and the different shards, are there use cases or types of aggregations where you are in danger of getting incorrect results due to the communication?
Due to the communication?
Just the fact that each node is going to the different shards, and the shards might not have a goal to.
Shards, certainly by design, a shard has 1/nth of the total view of the data, where n is the number of shards. So a shard would never see everything. So the general model there is that when you submit a request to Elasticsearch, you hit any node, what's called the coordinator node, and then that node will look at what we call a lookup table called the routing table to find where all the data lives, where all the shards live throughout the cluster. And we'll delegate that to the data nodes to run their search. And we'll get the results back and then compute the end result before giving it back to the user. So the question is, how does the coordinator know that he got the right results back from the data nodes?
Or are there any pitfalls, like a poorly formatted query, or not poorly formatted, but any type of query that's sort of more likely to produce inaccurate results, or in danger of producing inaccurate results?
No, there's no like inherently less accurate query, but I should probably take this time to remark that there are some calculations, such as a percentile calculation, which are by design inexact. So there are these mathematical ideas from a while ago called Q-digest, and then a more recent implementation of that idea to call T-digest. And we use this T-digest idea widely in the aggregations implementation. And essentially what a T-digest or a Q-digest says is that when you're calculating percentiles, for instance, it's not necessary to look at every single element. There are ways of looking at only partial elements and then bounding the inaccuracy. So these are parameterized algorithms which can be tuned either for higher accuracy or higher throughput. And in general, we make a trade-off between that, and the defaults are pretty sane. But in the aggregations APIs, those parameters are exposed to you so that if you want, you can preference more for speed or preference more for accuracy. But the error is always bounded within a definite range.
So aggregation problem you mentioned here, I think is, it's just a subset of trying to discover exact semantics from a completely constructed syntax tree. Discover exact semantics from syntax tree. That is the downside is for serious problem, you both can have running time exponential running time complexity as well as space complexity. So I don't think right now, because you cannot make your cluster truly elastic. If you can make it, you're gonna be next Google, or Google gonna go away, gonna be replaced by you. Seriously.
I'm sorry, I don't follow your question.
No,
I don't understand.
Yeah. So I mean, my comment, my point here is the aggregation problem you mentioned here is just a subset of trying to discover semantics, exact semantics from a syntax tree. That is the problem. That problem even has not been solved by Google right now. Even their cluster is truly elastic for sure, close to real time. That would be a tough problem.
Maybe we can take it offline, because I'm sorry, but I just don't understand the question.
It's not a question. I'm making a point.
Okay. Well, the point is lost on me.
So let's say you're just doing single level aggregations and you have a reasonably large database with a number of fields that you don't know ahead of time. And you kind of want to find the top 3 best aggregations, the ones that are most evenly distributed through the different buckets, let's say. So you want to, going back to your travel agency example, for instance, you want to put the best that's on the left side, the most ideal one that allows them to split up the data in most intuitive way. How would you go about doing that? Would you have to query all the different aggregates and compare the buckets with most even distributions across all the different aggregations, or is there a smarter way to do it?
I'm not sure I follow, because on one hand, you want to.
Some of the aggregations might have all of the documents in a single bucket. That would not be particularly helpful to provide as a class, right?
Some of the aggregations might.
So if you did an aggregation across a particular field, all the data might have the same value. It might all end up in one bucket. That would be particularly helpful to present as a facet on the left-hand side, right?
Right.
So instead, you want ones where they're evenly distributed throughout all the buckets.
What is evenly distributed?
The documents are evenly distributed.
Based on? So the idea here with aggregations is that they're a tool for you to inspect the size and shape of your data, but the data by definition has certain elements, attributes, dimensionalities that it's assumed that you as the owner of your application knows.
And let's say you don't, but you just have the data and you want to present the best possible facets. So you could index each facet, compare the buckets in each facet, and look for the most evenly distributed. Rank your aggregations based on the most evenly distributed set of documents across the buckets in each aggregation. But that would be pretty time consuming, and I'm wondering if there are any smarter ways to do it.
I'm not sure because you said you want to find the best aggregations and sort of a value judgment as to what is the best.
No, I'm giving you a metric. The metric is the most evenly distributed, where the documents are most evenly distributed. Let's say you have 10 buckets for each aggregation, and you want to find the aggregations that have the documents distributed in those 10 buckets for each field. You want to find the best field to do the aggregation.
You want to fit an aggregation to a fixed number of buckets such that all buckets have the same number of elements?
Not that they have the same, you just want the best distribution. I'll try and explain that.
Yeah, sorry.
You mentioned that when we do aggregation, then so you're going to get all the data from different data nodes, right? Then it seems to me that one aggregation is going to be operation is going to be very expensive. So let's say I have a request coming 100 requests coming every second. It's going to make my Elastic cluster freaking out. So is there any way that I can define the schemas or index some way that it can support me with the aggregation with multiple levels, let's say 2 buckets, bucket over bucket, right? Is there any way I can define the index somehow so that it doesn't have to collect all the data from data node to the coolnet every time and able to return the result in a certain amount of time that I can be accepted.
So, if I heard you correctly, you're concerned about running aggregations impacting the service level of interactive ad hoc queries that others might be doing at the same time?
Yes, yeah, this seems let's say I make 100 aggregation requests per second. It's every time I did that, and my whole Elastic cluster is freaking out. Is there any way that I can define the index or the schema somehow so that it can avoid that? That's my question.
Well, the nice thing about aggregations is you don't have to do any preparatory work on your index. There's nothing special for you to do, nor are there any real knobs that you could tune. At the end of the day, an aggregation functions very much like a search query, with the exception that there'll probably be some more CPU activity on the coordinating node at the end of the process. Is this something that you're saying you have seen on your cluster?
So my problem is, let's say I send 100 requests per second. Each of the requests is an aggregation, number of people for a certain age range for a certain state, right? Something like that. So so that query is bucket, 2 bucket level. So every time I send that query, then my Elasticsearch cluster is freaking out. So my question is, is there any way I can do with that?
I'd like to keep questions as much as possible, more general. But I think what we're going to do is take one more question and then we'll wrap it up. Some of our folks are here, so we can do some questions afterwards. Maybe I'll have all the people who are Elasticsearch experts kind of go to the front at the end, so you'll know who they are, and then we can do a little bit of Q&A afterwards. But I think you have a question.
Lucky enough to see that question. So can I apply our aggregations to indexes that have parent and child relationship. So that means like I have the parent-child documents, and then they become different indexes, and then for example, my users is parent, and then user associated with a lot of activities, where activities sit on other indexes where they have this child relationship. So can aggregations provide, can I do aggregations on this kind of scenario?
Not today. In principle, I don't see any reason why not, but there's nothing in the grammar today for describing aggregations that would allow you to say, given a bucket based on index A where my parents live, I want to do a calculation based on index B where my children live. I think that's interesting. I don't think there's any inherent reason why we couldn't do that, but nothing like that is exposed today.
Thank you, Andrew. So we can keep going. Oh, do you have more to present?
No, I don't, but we can keep talking. Questions?
Yeah, so I think we'll wrap up now. So let's give Andrew a big. And, I think, Krijn, if you want to come up here, maybe we can just do open Q&A. So at this point. Sorry. Before that, we have a few announcements.
Yeah, just wanted to thank you. I think, Andrew, you did a great job. I think your story is you want to be the first presenter next time and let Krijn take the questions at the end. It's tough part. So I'd like to thank the Elasticsearch folks, Andrew, Krijn, Sandy Boy, who is my primary contact here, and my partner in crime in the back from Cisco, Sujit. Does anyone have any announcements or anything like that you'd like to make? We're going to start trying to do this at the end. If you're all shy, I'm looking to hire people with Elasticsearch skills to be consultants, so I'd be happy to chat with you afterwards if you're inclined at all. Anything else? I can't believe everyone's this shy. I mean, technical people are rarely this shy. I don't understand the issue. But anyway, thank you very much. Our speakers will stay around afterwards, and the Elasticsearch folks are going to come up front, Sandy, so if you want to corner one of them. Oh, okay.
He's on our blog. He's the leader of our blog staff team and very experienced user of Elasticsearch as well. Krijn, of course, who presented yesterday, is back there. Kevin, who's our VP of engineering. So he knows a little bit about Elasticsearch as well. So definitely call on.
Why don't you guys move over to that side of the room so we can keep you from getting to the exits? That's the right approach. So thanks very much for coming. We'll be announcing what we're going to be doing next month. Keep an eye on the meetup. Thank you for participating. If you'd like to see more meetups like this, different kinds of meetups, more technical meetups, please let us know. Send us some information so we can know how we want to tune this so you guys can get more value out of what we're doing.